So I'll go ahead and start recording. So again, my presentation is really going to focus on the background of the DEQ water quality planning process. Christy Meredith, my colleague, was the primary author of this document, and she's going to go into a bit more detail on how metals are impacting specific streams in the Beaverhead watershed. So thank you again for joining and hopefully taking a look at that Beaverhead Metals TMDLs document that's out for public review and comment. As promised, a little background on Zoom. I think we kind of already went through a lot of this. But again, you can mute yourself or stop video down at the bottom. Please feel free to use the chat button to ask questions. We'll hold off on questions until kind of a Q&A after Christy and I give our presentations. I guess, again, I wanted to remind you that we're going to be recording this presentation and posting it on the project website. If you do have questions during the presentation, again, put it in you hit the chat box and then type your message here. I guess just to kind of practice, we're going to use the chat box as a sign-in. If you can put your name, your affiliation, your interest in the Beaverhead watershed, and please go ahead and add contact information if you'd like to receive any follow-up from me on this presentation. If you don't want to put that out for everybody, you can use the drop-down menu there and just send it to me or Christy or Moira. So that's just kind of some housekeeping there. So we'll go ahead and begin. Got a lot of chats going on. Again, you know, this meeting is to introduce the overall concept of a TMDL, and then we'll go into some detail on what this Beaverhead Metals TMDL document contains, and really encourage everybody to review the document and provide your comments and insights, really to make the document useful and usable for everybody. So again, the document's broken down into 3 sections, and our presentations will kind of follow a similar format. Part 1 introduces the project, provides a description of the area, and discusses the DEQ water quality planning process. So that includes water quality standards, monitoring of water quality, and then TMDL development. Part 2 is the real meat of the document, which Christy's going to present and discuss. And then part 3 is about what happens next. You know, how do we implement actions recommended in this document to improve water quality? And we're both going to touch on that a bit in our presentations. To access the draft and provide your comments, you can visit this website. Moira is going to pop that into the chat box, so you can link to that. And I'll just go ahead and show everybody. This is the public comment. You can link to the document. It has the main body of the TMDL and the appropriate appendices for the Beaverhead draft here. And then you can click on this link, which will send you to our comment area where you can provide your comments. So again, really great to get feedback on this, and we appreciate anything people can provide. So the next few slides are really background on TMDLs, getting at why we write these TMDL documents. For one, you know, we want to, as a step in the process, to improve water quality. And second part of that is that we have to. First, as part of our mission as a department, to protect and restore water quality. And Montanans have overwhelmingly said they want healthy streams and rivers, so much so that in the 70s, we put it as an inalienable right as well as an obligation in our state constitution. So second, we, DEQ, are legally obligated to write these under our authority that's delegated by the federal government, that's EPA, through the Clean Water Act. So here's the Beaverhead Watershed. You're all already pretty familiar with this, I'm sure. You know, all the water drains from surrounding mountains, the pioneers up here at the headwaters of Grasshopper Creek. Blacktail Deer Creek comes out of the Snowcrest Mountains, and then the main stem of the Beaverhead flows right out of Clark Canyon Reservoir, which kind of brings in all the water from the Red Rock area. And all that water flows downstream and through Twin Bridges to meet with the Big Hole and Ruby River to form the Jefferson River. So again, this is the area we are discussing. All of the streams highlighted in red are impaired by metals. So impaired means that they don't meet our state water quality standards, which I will discuss a bit more later. This also means that they don't fully support their designated beneficial uses. That means fish and other aquatic life, and in some cases, drinking water or agricultural uses. This map just helps put this project in a context a bit. DEQ has completed over 70 TMDL documents to date with more than 1,300 approved individual TMDLs. So our planning is guided by the State TMDL Advisory Group, the STAG, made up of representatives from different types of groups, from ag to recreation to mining, several others. These are all designated in the Montana Water Quality Act. So this map is all of our completed and planned TMDLs. You can see here's the Beaverhead TMDL development in progress. That's this metals document. There's also been sediment TMDLs completed in the Beaverhead, as well as a temperature TMDL for the lower Beaverhead River. We also still need to prepare nutrient TMDLs because the Beaverhead has some nutrient impaired streams as well. We also are working on TMDLs for the Red Rock, which is just upstream of the Beaverhead and is potentially contributing some of those pollutants to the Beaverhead. So we'll be working on that and keeping everybody apprised of that. So really I wanted to highlight that the end goal for us is to produce a document that's going to be used, not just one that's going to sit on a shelf or fulfill our statutory obligations. The document can be used to address problems and improve water quality. So TMDL is really just one of those steps in our planning process that results in management improvements and then restoration projects on the ground, which is what this map shows. All the dots on this map are projects that our non-point source program at DEQ has helped fund through Section 319 funding is what it's called. So this is a snapshot, and really a broad array of partners are really working on projects across the state. Forest Service, the BLM, local watershed groups, conservation districts, putting other projects that aren't represented on this map, but we're doing a lot of good work. Then I wanted to show a quick time lapse of some mine reclamation and a stream restoration project up on the Little Blackfoot River, just to give you an idea of what it means to implement this metals TMDL. So this project was, done through partnership with our Abandoned Minelands program, as well as led by Trout Unlimited. So Telegraph Creek runs right through here, or did run right through here. You can see the mine waste piles. There's a bunch of piles up on off the screen, and then this big pile here that was impounding most of the flow from Telegraph Creek. And those were all contaminated sediments with lots of heavy metals. So these big machines are in that floodplain, removing those contaminated sediments, bringing it to a nearby repository. Telegraph Creek is currently flowing in that pipe you see on the lower right. And so once all the contaminated materials are removed, they can begin the revegetation process, start really scratching in a stream channel where they think the Telegraph Creek used to be, or where it fits within its natural setting there, restoring some of the natural stream functions, and clearing out metals from Telegraph Creek. So a lot of work goes into it, a lot of partnerships, a lot of different funding sources. So in order to implement this TMDL, it's going to take a kind of concerted team effort to make that happen. But it can happen, and the results are really great when it does. So gosh, won't listen to that. So this is Telegraph Creek right after the implementation happened. It looks messy, but that's what healthy streams look like. They're a little messy. All this vegetation, all this slash is going to really help vegetation grow. So TMDLs, like I said, fit into this broader water quality planning process here at DEQ that results in getting good projects like that on the ground. So that end goal, it's more of a cyclical process here. So for metals, this water quality planning process begins with setting standards, and those standards are numeric and they're codified within DEQ7. So this has all of the metal standards within that. DEQ7 is updated every 3 years, and it's based on the best available science to protect beneficial uses. So these little pictures represent the different beneficial uses: fish, aquatic life, drinking water, then agriculture. Here, this is a aerial shot from the Beaverhead of some of the pivot irrigation going on. Some pollutants and some metals can impair agricultural beneficial uses. So, and then once we have standards, DEQ and its partners collect water quality data and determine whether it's meeting those standards, and help identify some of the sources of pollutants. In some cases, those sources are obvious. This leaking adit is pretty clear to most people as a problem, but in some, you wouldn't realize there is a problem with water quality. This is Grasshopper Creek. The beautiful morning I took this photo. You can see some remnants of historical mining, but you might not necessarily know, or at least the average person wouldn't know that there might be a problem. But Grasshopper Creek is impaired by lead. So I guess really to get to the point, what is the TMDL? This really just tees up Christie's presentation, which is going to go into detail on the TMDLs created for the Beaverhead watershed. So first of all, it stands for total maximum daily load. It's maximum amount of a pollutant that a stream can carry and still meet the water quality standards set in DEQ7. A lot of people like to think of it as a pollution budget, where pollution can come from and how much you need to set. But I really like this photo in the bottom right. I think it does a great job of illustrating the idea of a TMDL. If you imagine that the donkey is the water in the stream or river and the boxes are the pollutants, the beneficial use in this analogy would be delivering those packages. If there are too many boxes or pollutants, then the donkey or the water can't function properly. When we talk about a load reduction, it is how many of those boxes need to be removed before that donkey comes back to earth and can deliver those packages. You can imagine that with fewer and fewer boxes or less and less pollution, that donkey can function even better. So to move away from that analogy, a TMDL is the maximum amount of pollutants that a stream can have while still functioning properly, meeting those beneficial uses that we talked about. So the diagram in the upper right really shows an existing load of pollutants in a water body from natural, non-point, and point sources. The load exceeds the amount that will allow the stream to function properly or support its uses, those drinking water, fish and aquatic life, and agriculture. And then, so we move to the right here, and that TMDL really defines how much the stream can take to meet those uses and the amount of reduction that's needed from those various sources to achieve that TMDL. And then I'll talk about this a little bit more in a minute, the different sources and how they're allocated. So when we talk about sources of pollutants, they come from natural sources like eroding hill slopes, wildlife, things like that. Then there are point sources, which are discharged from a specific point or pipe, and those will require a permit. Non-point sources, which are diffuse, but are the results of human activity like mining in the case of metals. So you can see something like the historical tailings along Rattlesnake Creek, or just changes in stream function from historical placer mining. Kind of lowered and a little more channelized than it would normally be. So TMDL gives allocation to all three types of sources. Point sources are given waste load allocations in the TMDL, and as I mentioned, those are achieved through permits issued by DEQ to discharge limited amounts of pollutants to surface water. Non-point sources are given what's called a load allocation, but addressing those issues or those sources is voluntary. So that's a major distinction between point sources and non-point sources. Point sources are discrete and controlled by permits. Non-point sources are diffuse, and addressing them is voluntary and requires a lot of support from community. DEQ also supports non-point source project implementation, as we saw with that Lily Orphan Boy project. We can help support through funding and technical resources. So as you see here, we've given load reductions to non-point sources and point sources, but you can't reduce natural sources. So they don't have a required load reduction. So that about wraps it up for me. But before I hand it over to Christy for really the meat of the presentation and document, I just want to run through the process again. First, we define water quality targets, which in this case of metals here is based on numeric standards in DEQ 7. Using those targets, we can define the TMDL. That's how many packages our donkey can carry. And then we determine as best we can where the pollutants are coming from. And then we give allocations to point sources and non-point sources. And finally, in this case, the document provides recommendations of projects and practices to address these sources, similar to the work done on the Little Blackfoot. So now I'll hand it over to Christy to talk in more detail on where and how TMDLs were developed for different water bodies in the Beaverhead watershed. So Christy, take it away.
Okay, thank you, Eric. So as Eric mentioned, I'm going to talk about a summary of findings related to the TMDLs for the Beaverhead metals. Before I go into that, I just want to mention why we are concerned about metals in the first place. Metals have harmful effects on aquatic life and humans, including cancer, osteoporosis, impaired kidney function, and metabolic function. And this is a pretty complex diagram that just shows some of the effects of cadmium on proteins in the body in red and the resulting functions in purple. Similar effects are found for the other metals that were measured in the Beaverhead streams. So in order to determine if a water segment is impaired, water samples are collected. And in this case, water samples were collected from 2014 to 2017 by Montana DEQ, and in 2009 by the Beaverhead Watershed Committee. And those levels of metals in the water were compared to water quality standards, as Eric mentioned. Aquatic life standards, which are harmful at short or long-term exposure. And only 10% of samples were allowed to exceed the standard. If more than 10% exceeded the standard, then the segment was considered impaired. Also, there was a human health standard, which was the level that would be harmful to humans, and no samples can exceed that standard. How do metals get into the stream in the first place? Metals erode from rock that is exposed to air and water. So during mining, there is material that is excavated, and that material is left behind. Any of that has metals in it, when exposed to air and water, can degrade and run into the stream. These metals can also bind to sediment in the hillsides and adjacent to the mining operations, and this can go into the stream and then get resuspended into the water during storm events. So on the left picture here, we have a photo of tailing piles, which are piles of rock and sediment that contain metals and that are adjacent to Grasshopper Creek. On the right, we have some turbid waters in Stone Creek. These waters contain metals. The sediment contains metals, which ultimately gets into the water. That's why we evaluate metals at high and low flow. So for instance, here we have a diagram showing metals depicted by these yellow points in the stream sediments and in the banks adjacent to the stream. When we have a storm event, those sediments are mobilized, moving that into the water column, which can affect aquatic life. Now I'm going to move into talking about some of the actual results for the TMDL. Here we have the 9 impacted segments on the left and the metal impairments above. And we can just see an X describing which impairments occurred in which segment. Upper Rattlesnake Creek and Lower Rattlesnake Creek, there's essentially 2 segments for Rattlesnake Creek because they're just so different that they were separated into 2 different segments for the analysis. This was also done for Upper and Lower Stone Creek. All of these impairments were aquatic life impairments except for arsenic, which occurred in Steele and West Fork Blacktail Creeks, and this was a human health impairment. Now I'm just going to give some examples of what TMDL document. Here's an example from Upper Rattlesnake Creek. We have a map of the watershed, which is the land area that flows into the creek. The impaired section is highlighted in purple here, and Rattlesnake Creek does flow from north to south. And these pop-outs represent the sites that were sampled. We can see that there were 6 sites sampled and 3 were impaired for lead. These occurred downstream or near Argenta, suggesting a source in that area. A 92% reduction would be needed at low flows in order to meet the water quality standard, and a 96% reduction would be needed at high flows based on our analysis. In this map, you can see these dark points, which are the abandoned mines, which are past mines that are no longer regulated. The reductions basically would have to be in those abandoned mine drainages. Nearly all of the source can be attributed to abandoned mines. Moving on to West Fork Blacktail Deer Creek, which flows from south to north. Similarly, we can see the watershed area and the impaired section represented in purple. We can see there were 5 sites sampled and the 3 downstream sites were impaired for arsenic. And this was a human health standard impairment. A 38% reduction would be needed at high and low flows to meet the standard. We can only see 1 actual documented abandoned mine in the watershed. However, it's possible there's more mines that have not been documented, and we are attributing this impairment to abandoned mines. Finally, Upper Stone Creek, which was impaired for iron. This was the only segment that we evaluated that has active metals permits. So there are several active mines that are allowed to discharge iron into Upper Stone Creek. However, these permittees are required to meet water quality standards. So here you can see the watershed again, and it flows from south to north. We have the 3 sample points in Upper Stone Creek. The abandoned mines are represented by these dark points, and then we have the actual point source permittees in green here. And based on the analysis, 80% of the iron is from abandoned mines and 20% is from point sources. A 22% reduction would be needed at low flows to meet the standard, and a 75% reduction would be needed at high flows. I'm not going to go through any more examples, but these are in the document, and I can be contacted if there are any questions about these findings. Now that we have a better idea of what streams are impaired and the level of reductions needed, how do we get a healthy stream? Some actions that can be taken are removal of mine tailings, those piles of sediment and rock that contain metals, maintaining the tailing ponds in the watershed that do exist from abandoned mines that have been designed to trap that sediment before it gets into the stream, making sure those are continued to be maintained. And then DEQ will continue to issue permits and require permittees to monitor their point discharges to ensure they are meeting the standards. Other practices, any practices designed to keep sediment out of the stream will also keep metals out of the stream, such as streamside vegetation management and reducing erosion. Also, irrigation water management can affect metals concentrations because when water is taken out of the stream, any abandoned mine that is present will have more of an impact. So ensuring there are adequate water flows in the stream is also important. Next steps. The Metals TMDL document can be used to inform watershed restoration objectives and priorities into the future. The job of DEQ staff is to assist with projects through the non-point source pollution and abandoned mine lands programs that can provide technical and financial support. And many projects are initiated and accomplished through partnerships with organizations like the Beaverhead Watershed Committee, which was formed in 2001 and has multiple stakeholders that are concerned about the Beaverhead Watershed, the Beaverhead Conservation District, Trout Unlimited, and the Nature Conservancy. The Beaverhead Watershed Committee or the Conservation District can be contacted to get involved. There is already a watershed restoration in place for the Beaverhead, which came about after the temperature and sediment TMDL or in conjunction with that. It does not include much about metals. However, as I mentioned, actions to reduce sediment will also help metals. This plan can also be amended in the future if needed. In addition, the Conservation District has already been undertaking some action to identify sources of sediment in Grasshopper Creek, and that analysis suggested the remediation of several abandoned mine lands. And with that, we will take any questions.
And questions, you either type into the group chat or you can raise your hand.
This is Zach. I don't have any questions, and I've been looking over the document a little bit. I'll just say that once this comes out and we actually look at, possible projects to address some of the impairments, I think that's when I'll at least start to have actual questions about some of the nuts and bolts of this, but nothing jumps out at me right now.
Thanks for sharing. And you're also welcome to submit public comment, which we'll talk about here shortly. Does anyone else have any other questions?
This is Peter with EPA. I don't have any questions at this time, but thanks for running through that.
Thanks, Peter. I guess I won't leave any more awkward silence, and we'll just move on. So here, this kind of shows you how to submit comments. Moira put those links into the chat box so you guys can check that out. I guess I can share the actual website. So here's our wiki site, which has a lot of the project information on it. I will be posting the posting this presentation on here. It's already up PDF form. I'll be putting the recording up here. Here's the public notice. Zoom is messing with me. So here is where you can submit your comments. There's comment period is open for Beaverhead Metals TMDL. Here's the comment page if you want to take a look, but pretty straightforward. And again, always feel free to contact me, Christy, or anybody else here at DEQ if you have any questions or comments. But otherwise, I think that's all we have. So I want to thank everybody for attending. Thank you.
Thank you both.
Thanks,
everyone,
Eric. Thanks, Christy.
Thank you.
Thank you.